Hello, hi everyone. Welcome to our session today. The fireside chat for scaling Terraform in regulated industries. My name is Moria Dror. I'm the EMEA regional lead at the Reactor program. I'm going to be your moderator today, and I wanted to share a bit about the Reactor program before we kick off the session. So for those of you who are new to the Reactor program is a basically technical hub for developers that we share free learning opportunities on different technologies around Microsoft products and AI in both online and in person. We have 10 in-person locations worldwide where we have physical reactors, but we also offer our programming online, such as today's event. You can watch our events on demand on our YouTube channel. I'm going to share all the links soon in the chat. So if this is your first event, I highly recommend you to check out the YouTube channel and see the previous events we hosted. As I mentioned, we have 10 locations worldwide when we have a physical reactors. But don't worry, even if you're not located in one of those locations, if you join our newsletter, you can receive a monthly email with all the upcoming events, depending on the time zone you are joining from. And we have multiple events every day, even in different languages. So if you scan the QR code now, you can register to our newsletter and receive this monthly email with the upcoming events. You can also check out our website and find out more about upcoming events that we have. Sorry about that. Another option I wanted to share with you where you can find out more information is our Azure AI Foundry community. If you scan out the QR code now, you will get to our Discord community where you will find other community members discussing different technical areas. So if you scan the QR code now, you can reach the Azure AI Foundry community, and I'm going to share the link soon in the chat as well. Microsoft Learn, if you're not familiar with our platform, it's a free platform where you can access free learning opportunities, learning path, learning modules, where you can choose the technology that you are interested to learn about, the level that you are joining, if you are a beginner or advanced, how long you want to invest in the learning, and the Microsoft Learn platform will offer you basically a tailored learning path that you can choose depending on the area that you prefer. It's all free, of course. You can do it anytime from home, for anywhere you are at any time. So you can scan the QR code on the screen now, and the link will be in the chat soon as well, where you can access Microsoft Learn. Before we start today's session, I wanted to quickly go over our code of conduct for all of our Microsoft events. Please, we ask you to be friendly, patient, and respectful during this session. Take a minute, please, to read the code of conduct before we start the session. Okay, and without further ado, I'm going to hand it over to both of our speakers today, Rosemary and Jared. They are going to deliver the fireside chat today. So I'm going to let them introduce themselves. Rosemary, Jared, over to you, and enjoy, everyone.
Thank you, Moria. I appreciate the introduction. Hello, everyone. I'm Rosemary. This is Jared. Today, we're going to be talking about scaling Terraform, not just in regulated industries, but I think a number of the practices we'll be talking about might apply, especially if you are working in a regulated industry. We will be taking questions. So if you have questions or comments, please put them in the chat. We will be answering them as we go along. We might not get to them immediately, but we will be answering them. As Moria mentioned, I'm Rosemary Wong. I'm a developer advocate at HashiCorp, an IBM company. I've worked in the infrastructure as code space for quite some time, since the beginning, probably since Terraform was released as a project for folks to use. I was trying it out. And over the years, I've learned how to deploy infrastructure as code, worked with many organizations who are trying to scale it, adopt it, and ultimately, in some ways, trying to aggregate and consolidate their approaches to infrastructure as code practices in the realm of Terraform and many more. Jared, would you like to introduce yourself?
Yeah, sure. I'm Jared. I'm a cloud solution architect at Microsoft. I work in a team that's responsible for developing Terraform modules that our customers use. I've worked with infrastructure as code for a long time and helped customers scale it out. And I used to work for Hashicorp as well before I worked for Microsoft. So I've got a lot of experience with Terraform. So hopefully I'll be able to answer some of the questions that we get today and give you some useful advice from the real world, hopefully.
Yeah, tips and tricks. I think that's the key, right? The things we wish we knew when we first started infrastructure as code, and we made the mistakes along the way. So hopefully these are a list of practices that you can take and apply to your organization, and you don't make the same mistakes, right? That we started with. But we should probably talk about what is infrastructure as code in the first place, right? Because there are many ways in which you can codify infrastructure deployment, configuration. So what is infrastructure as code, and how does it help with scaling the deployment of infrastructure?
Yeah. Do you want me to start? Sorry.
Yeah, you start.
Yeah.
Why not?
Okay. So infrastructure as code is basically treating your infrastructure as you would any other code that you're deploying. If you're deploying application code or database scripts and things like that, you would source control those things. You would manage them as a team of people, and you would make sure that they're of a decent quality. You want to be able to audit what changes are happening to that code base. Historically, that's not always been the case of infrastructure, right? From a more traditional perspective, people have been SSHing onto virtual machines, making changes, physically racking infrastructure in the past. But now with public cloud, it's more about automation. But still, people are going into the portal in Azure, for example, and making changes to infrastructure. And there's not a proper audit of what's happening there. And it can be difficult to find out why something changed and when it changed and who changed it. Infrastructure as code brings that same level of governance that you get with other development practices and bringing it to infrastructure. I think, in summary, it's slightly different from other languages in that it's a declarative language. Maybe that's something you want to touch on, Rosemary.
Yeah. And I think it's definitely a challenging paradigm shift for someone who's used to clicking in a console and saying, oh, I'm just going to make the changes. It's really easy to go into Azure, create a subscription, and spin up resources, right, in resource group. But if it maybe works for one person, but I think if Jared was added to the same team and we're trying to use the same database or we're trying to make the same edits to a network, those changes might conflict, and one change might conflict with the other and therefore destabilize the overall system, right? So codifying it becomes really important, especially when it comes to sequencing those changes in order. I think that infrastructure as code tends to be declarative because we want to take away the complexity of the order of operations. I used to work in network engineering, and typically it was imperative, right? You would say, I want to configure this interface with this step, with this IP address. And you would have these sequence of changes that you would have to explain how the system should make these changes. In infrastructure as code, we tend to favor a declarative approach in which we just say, this is the end state we want to achieve. It's up to you as the infrastructure as code engine or tool to dictate how we're going to get there. And the way it dictates how we're going to get there is that underneath it all, it is imperative. It is doing create, read, update, and delete commands. But those create, read, update, delete commands are atomic. They're small, and they're basically sequenced in a way that makes it a very stable set of changes, right? So a lot of the logic handles the order of operations of applying those changes, which makes it a lot easier. So if you are looking at Terraform and you're trying to write it, it's in HashiCorp configuration language. It's a domain-specific language that describes the end state of what you want to achieve, and what we call plugins or providers dictate how it's going to get there. But you, as someone who's writing it, you don't have to figure it out yourself.
Yep,
Did I miss anything on declarative imperative?
No, that's right, and I guess that touches on the subject of what is not infrastructure as code, which is, I would probably say, Bash scripts, PowerShell scripts that are making calls over SSH or talking to the cloud provider endpoint, and are built in an imperative way. That's not what infrastructure as code is, right? We are talking about that declarative language. If you're writing Bash scripts and things like that, then you've got to think about how that script is going to be idempotent, how you can rerun that script without causing problems for yourself. With Terraform and its state management, it takes care of that for you, right? You can run the same declarative code over and over again, and you'll know you get the same result. It's not going to suddenly decide to start destroying everything and recreating it. Whereas with an imperative language, you've got to take care of that sort of thing yourself. You've got to check, does this thing already exist? If so, don't do anything. Otherwise, create it. There's a lot of things to care about there, but with infrastructure as code, it handles that for you. So
yeah. And it's not to say that there isn't a way for someone to use a declarative approach with a programming language, right? So Terraform itself comes with a domain specific language, and you can layer a programming language on top of it, right? There's there are options there available, but in terms of the general approach, as Jared, you pointed out, scripts tend not to be very stable in making changes, because we don't always test for idempotency, right? We also don't always test every edge case for what happens if we apply one change and it's an update, but really it should be a delete and create. So part of this is part of the ecosystem of a good infrastructure as code tool like Terraform includes this rigorous testing of how these resources get created, the order of operations they should be applied, whether or not a change should actually be an update, in-place update, or it must be a destroy and recreate, right? So all of these factors are in play. It's a lot of testing involved.
Yeah. And I guess the other thing that's maybe not infrastructure as code that we should call out is something like a provisioning tool like Ansible, Chef, desired state configuration, right? That's something that runs after the fact, and it mutates the infrastructure that you've already deployed. I wouldn't personally class that as infrastructure as code tool. I don't know what your thoughts are on that. But
no, they tend to be configuration management tools, right? So they're really for configuration. Now, there's an overlap in that some configuration management tools do some kind of provisioning of resources, but not in quite the same way as what you would perceive an infrastructure as code tool like Terraform to be doing. Yeah, it's a good call out. Commonly asked question: is the configuration management also part of infrastructure as code? So we talked a little bit about the basics of infrastructure as code as a practice, but of course, we're really talking about scaling, right? Because it's easy to, or some ways, it's easy to get the tutorial and to start writing it and to say, okay, I'm going to start incorporating this as a practice in my day-to-day development or deployment of infrastructure. But it's a lot harder to go from one person to hundreds of teams, right? So if I want to share what I'm doing and how I want to make those infrastructure changes across thousands of different developers, engineers who need to make changes to Azure, for example, there are some foundations we need to set in place. You mentioned version control, very important. You do have to have some capability of controlling and committing what changes are being made in some codified manner. But what are some other foundations that you've encountered that you thought, like, if I had done this from the beginning, it would be a lot easier for me to scale this to many different developers?
Yeah, so I think probably the biggest one for me would probably be modules and how you structure modules for sharing code, and also building standards into your your Terraform, right? So you've got many teams in your organization. You want those, every team that's deploying a virtual machine or deploying an app service or deploying a network, you want them to do it the same way, so the same standards. And the best way that you can do that is by having reusable modules that every team uses that have got your standards for security, cost, and other factors built right into them from the get-go. So they've got those like well-architected features in there on the standards that your organization needs. So they might be even things like naming conventions and tagging and stuff like that are built into those modules. And that's how you can really scale with infrastructure as code, because the teams can basically take those modules, use them as building blocks to compose together into whatever architecture they need, but you know that they're using your pre-approved modules that have got those standards baked in. So I definitely, like, when you're first starting out with infrastructure as code, you're probably not thinking I need to build all these modules up front, and maybe you don't, but it's something you need to consider as you evolve. Or reusing modules that somebody else has already built as well is a way to speed up your adoption of infrastructure as code, so you don't have to reinvent the wheel every time as well.
Yeah, and I guess it's a good question overall, though. But you maintain the Azure Verified Modules. How do you decide which modules are important to write, right? Because this is a question that an organization is going to encounter. Am I looking for the demand for the 80% use case? Am I just picking and choosing what's most important, what's secure? How do you make decisions on which modules are important to develop first?
Yeah. So I think it's slightly different for us developing Azure Verified Modules, because we have to basically cater for everybody and every scenario.
Right.
So we essentially we're going to have a module for every single resource that you can deploy into Azure, and it's going to be have those well-architected aspects applied to it through around security and resilience, reliability. So slightly different for that, but I think in your organization you want to be trying to think about what are the common patterns that you see repeated over and over again. Like, you're always deploying Kubernetes clusters, you're always deploying app service or an N-tier application that's got SQL, it's got storage account, it's got an API, it's got a web app, it's got that. Those things are always getting deployed together, and teams are deploying web applications into that architecture. That's the kind of thing that you want to think, well, this team's writing a module to do that, this team's writing a module to do that. Let's have a standard around this, a pattern module that everybody can reuse. That'd be sort of where I'm thinking. Like, as soon as you see any repetition, I think that's a good starting point. But also, if every team's having to go through some kind of InfoSec review as well, and the same things are getting picked up over and over again, that might be another driver for you to start looking at those individual resource types, and whether that be a virtual machine or an app service or similar, and how you could make those things reusable with the standards in them as well.
Yeah. And I think
I don't have a perfect answer. I would just say don't build. The only thing I would say is don't build something that you don't know you need immediately, right? Don't build something for over engineer it for something that you might need at some point in the future, but you don't know for sure. Like,
it tends to be like networking. Networking tends to be a good foundational module that folks aim for first. And some of the other ones might be like virtual machines or other things that connect up to each other, load balancers. Some things that maybe component wise are a little complicated to add. So, and an engineering team or a development team that doesn't really have some of the knowledge, it just might be better to hide that away, right? And make sure that those things are standardized. So I tend to see networking being a really common first module to start with. If there's a relatively new infrastructure as code practice or a sort of an intermediate infrastructure as code practice, I also see landing zones, which we can talk about. But a landing zone, which is like, what is the basic subscription with resource group that I would set up with access control available to a team, and they can self-service that. And one thing that I think is worth calling out is becoming more of important and more, I think, embraced as a practice, and that's module testing. Making sure that you are treating your modules as if they are code and other code libraries. So they are artifacts unto themselves. So you should be versioning them. You should be testing them. There are unit tests, integration tests, end-to-end tests available that you can be writing. And then if you have, let's say, root modules or modules that are sort of the actual environment description, like production, QA, staging, those you could tend to test end-to-end and be fine. But modules allow you to also test individual components, make sure they're working, and decouple dependencies between, let's say, like a network and any upstream services that depend on it.
Yeah, agreed. And testing modules is the different layers of testing. So the unit testing, integration testing, the end-to-end testing, and you'd be using those you'd be doing that in the end-to-end test would be like using it in a way that you think you're going to use it in production, right? So you get in validation that it's deploying what you expect it to deploy, but you can also run policies code against that as well and validate that it's meeting your standards as a business. It could be Azure policy as well, because you're actually deploying it into Microsoft Azure, so you can actually validate that it's meeting Azure policy as well. But yeah, policies code can also check for like your security standards, like you've not got a public IP on a virtual machine, or you've not got a public endpoint on a storage account, all those common things that you might expect. But it can also test for things like you are enabling multiple availability zones on a service that supports it, that kind of stuff as well. So I know it's not testing per se, but you can run that against the modules that you're developing as well. So it doesn't have to be all the way further across when somebody's consuming that module that you do that kind of testing.
Yeah. What is policy as code, but unit testing for security and compliance requirements, right? Which is, speaking of policy as code, we have a question that came in about how do you use governance in Terraform? So we're going to try to put that up, but how do you use governance in Terraform for instance approvals or quota policies? And so this is what Jared was mentioning, right? You can use Azure policies to potentially control some of this, make sure there's a compliance check in place. On the Terraform side, you can use HCP Terraform, which is the managed cloud version of Terraform, or Terraform Enterprise, which is the deployed enterprise version of Terraform, and run something called Sentinel. And you can write Sentinel policies that are effectively just a unit test, right, for security. And it will test these attributes and say, okay, how, what kind of instance are you using? Is it a large instance? Is it an instance that's on this approved list? Are you using instances that we do not approve because of cost reasons or because of just general security reasons or management reasons, right? You can add them to a list and dictate whether or not those changes get applied. So what Sentinel will do is it will evaluate the Terraform plan. And so a dry run what is going to be changed. And if it detects that some kind of attribute doesn't match what you are expecting from a compliance standpoint or from a governance standpoint, it will not apply the changes, right? So it will either do a hard mandatory error, which says this is not acceptable, so you have to make an exception somehow, or a soft mandatory in which you have an administrator who is available to override and approve that this was a change that is allowed to go through. So there are two different ways that you can do governance, but those are the main two.
Yeah, and I think some of the other questions there are so quota. I'm assuming that's relating to cost and budgets. So yeah, you can do some cost analysis as well after that plan stage and look at what the uplifting cost might be, or the down. It might go down as well, of course. But you can look at the uplifting cost, and then you can use policy as code to say, if this is increasing in cost by more than 10%, say, or a figure that you choose, then block it and ask for an approval before it can move forward. That's one of the ways that you can do that, and that's before it even attempts to deploy anything into Azure. I think one of the other questions was, sorry, where was it now? Yeah, approvals. So we already touched on HCP Terraform, you can have an approval between the plan and the apply stage. You can also do that with any continuous delivery tooling like GitHub or Azure DevOps, right? You can generate the plan in one stage, and then you can save that plan as an artifact in your pipeline, and then you can have an approval on the apply stage, and you know that whoever's approving that would need to look at the Terraform plan, see what it's changing, and then approve it, and also look at the policies and things that have been run against it. One other thing you can do with governance as well now, if you use, we've got a provider, an Azure provider called AZ API, which you may or may not be familiar with, but that now has a capability called pre-flight checks. And if you turn on pre-flight checks in that provider, it can actually, when it runs a plan, it can actually validate against Azure policy. So you can actually validate and get some feedback on Azure policy, and also API validation as well, that you've got like valid IP addresses and things like that. But it'll also evaluate against Azure policy and tell you if it's a deny policy. It'll say you're not going to be able to deploy this because it doesn't meet the pre-flight check. So you can sort of belt and braces it and still be able to do it before you actually deploy anything or attempt to deploy anything. You can still do it at the plan stage. So there's a few different options available.
Yeah. And speaking of the Azure AZ API provider, there is a question about where some sample Terraform for standing up agentic AI services, right? And I think that's in preview or something. It's not something that I guess may or may not be in the Azure provider. In the Azure RM provider. So for folks who are not familiar, there's two providers, Azure RM and the AZ API. AZ API provider. So it may not, preview services or services that are not generally available may not be available immediately in the Azure RM provider, but they might be available through the AZ API. I don't know if there are samples available. We can find some.
Typically, so AZ API works against the Azure Resource Manager API. So anything that is publicly available in Azure, whether it's in preview or it's GA, you can manage it through Terraform using that provider. And then Azure Verified Modules is an initiative that I work on. We have resource modules and we have pattern modules. So there's like two layers to the modules. So pattern modules compose together resource modules into a usable architecture. And resource modules are wrapping an individual resource type, and that resource type might, for example, be Azure AI services. Like that's one of the things that would be a resource module. So you could see from the resource module, you'd be able to see, how to deploy that individual resource, or you could just use our module. And also, we are in the midst of developing pattern modules for Azure AI services and lots of different use cases for like RAG or agents. They are going to be available soon, and some of them might already be available. So I just don't know off the top of my head. But if you go to aka.ms/avm, you can see all the modules that we've got available there. And those modules are maintained and supported by Microsoft. So and we do a whole load of testing and validation on those modules.
Yeah. It's also worth checking out. Modules are typically really good for those who are referencing modules for their own organization. Modules are a very good example, right? So even if maybe an Azure Verified module doesn't have something you want, you can always check on it and see if there's a good pattern for you. And you can always redevelop whatever module you need.
Yeah.
Speaking of developing modules, does everyone need to learn Terraform? I think that's the most common question I get from scaling. Scaling Terraform, not just on the technical side of, architecturally, how does it make sense to scale an infrastructure as good practice, but should my software developers be learning Terraform? Do security teams also need to learn Terraform? I hear a large mix of folks who don't want to learn Terraform, and my general approach is, well, if you have a platform team or an infrastructure team who is investing in modules, who does have an infrastructure as code practice in place, try to limit the Terraform knowledge to that team, and offer some kind of self-service capability for someone to provision the Terraform modules, right? Whether it be through some other automation or some other form. That tends to be a more common pattern just because it's not scalable for every development team to learn Terraform. However, I have worked with organizations who take more of a DevOps approach, where a platform or infrastructure team just gives a landing zone, so an Azure subscription with some basic resources and access control, and lets developer teams decide what they want to do with it. And development teams have references to Terraform. They are expected to use Terraform, and they do have to learn it. So I've seen both patterns work, but I think more and more organizations that I'm working with now are converging toward the former model, which is make sure that we're offering modules for 80% of the use cases, so developer and security teams don't have to know Terraform at all. But I don't know if you've experienced something different, Jared.
Yeah, there's a mixture. I would say that the more forward-thinking organizations that I've worked with, like they're upskilling all their teams on infrastructure as code, right? They want their teams to have an understanding across the board of how their code, where the code is deployed to and how it's configured. So they're not working in a silo and don't understand what's happening there. As you said, that DevOps culture is really important. I think you'd have some experts on infrastructure as code that know it inside out and are involved in developing those reusable modules. But I would expect a developer to be able to raise a pull request in a source world against that module and be able to make basic changes to the Terraform code. I mean, it's not a difficult language to learn. If you're a developer, you're going to be able to pick up Terraform, right? And as a developer, I would suggest you probably want to have an understanding of it, in terms of your own career. But maybe I'm being a bit opinionated there. I feel like if you really want to progress your career, having that end-to-end understanding of how your software is delivered is important. But at the same time, I understand that not every company wants to invest in the people like that. But yeah, so it is possible. It is possible to do it a different way, of course. Yeah.
Right. Yeah. The thing is, I used to be of the perspective everybody had to learn Terraform in an organization in order to do it really well, and it just became clear that was not feasible in many organizations, especially because there was already sprawl. Right. They managed Azure through console, or through sort of just had let development teams manage however they wanted to with no standardization. And it became very clear that a lack of standardization overall was leading to quite a bit of drift, generally infrastructure security configuration concerns. And most of it just came from everybody doing their own process. And so now a lot of these teams are going back and they're basically forcing this model of saying, okay, no one has access to production. You can read it, but you can't write, or you can't change anything. You can't manually go in and click and change things anymore. You must do everything through version control. And so that's sort of a very hard shift for folks from a workflow perspective to embrace. But it's come to a point where they can security teams can no longer scale scanning tools and the management of these environments. And platform teams can no longer identify which resources belong where. So the result is now they're taking a much more disciplined approach to taking all of this and putting it into code.
Yeah, and I agree with that. I don't think anybody should have standing access to production, and everything should be deployed through like a service account, right? That's what it should be automated through a DevOps continuous delivery pipeline. There shouldn't be anybody running Terraform from their desktop. PC, right?
Yeah.
So, yeah.
I should hope not, but some people might. Yeah. Some people do. Yeah. Some people do. All right. So I think this is where we've brought this up a few times, right? Which is how you start or what is a good foundation to start in Azure specifically.
Yeah.
And so there is a common question in Terraform community, which is, how do you divide resources in repositories, right?
Yeah.
Infrastructure state is a big point of discussion, and we brought it up before, but Terraform manages the configuration of attributes and resources, but it needs to preserve some kind of state somewhere. So basically for every Terraform init that you run, it initializes a state file that stores a list of resources and all their attributes, their current attributes that Terraform knows of. And there's a common discussion point within the Terraform community where, well, we started by putting everything in one infrastructure state, right? So we put all of our Azure resources, including the creation of the resource group and every network, everything else in one giant state. And now it's becoming clear that it takes too long to apply these changes, or we ought to be decoupling some of these layers a little bit more carefully, because we don't make changes to certain things like the resource group that frequently. And so I guess, the question overall is there a good place to start, right? What should we really be subdividing into different states from the very beginning? And should they be in different repositories? Does it really matter how this is set up? It's mono repo, mono state, or multi repo, multi state, I guess, or mono repo, multi state.
Yeah. I guess starting from sort of scratch with Azure, I work on the team that's responsible for Azure landing zones, and that's our guidance that we provide to customers in the cloud adoption framework. So there's two parts to that. There's a platform landing zone. The platform landing zone is the central governance. So it's the management group hierarchy and the policies that are applied at different layers of that management group hierarchy. It's also the identity, the central identity. So if you're using Azure Active Directory, for example, that would sit in there. And also it's the connectivity, the hub connectivity, I should say. So if you've got networking needs and you need to be using like a virtual appliance to monitor outbound internet traffic, or you need to connect back to an on-premise network or to another cloud, that's that hub networking that sits within the platform landing zone. And then we've got application landing zones, and this is where the actual application workloads that your development teams are developing sit. And that's where you actually have the business value, right? It sits in there too. So the application landing zone, it could include a subscription, and it can include some networking, potentially peered back to that hub network if it meets that use case. And then it would have the actual resources that you're deploying in there. So whether the compute instances that you need to run and your data as well. We provide some guidance around how to structure those application landing zones. And we have a concept that we call subscription democratization. And basically we say, for each application or workload or team and each environment that team needs, then create a separate subscription. That's our guidance, right? So you would have a subscription for dev, test, prod, whatever however you do your promotion. And then that would be per application, or per team potentially, depending on how you want to divide it up. So basically, the subscription would be the boundary for cost, security, and also in this case for the state file. And so when we call it subscription vending, when we create a subscription through automation, we have Terraform modules that will do that for you. And we're extending our accelerators to help with that in the near future as well. But basically, when you vend a subscription for an application, you'll also vend either a workspace in HCP Terraform or a storage account in Azure to store the state file that team who are developing that application will then use moving forwards. So obviously, this is an opinionated view on it, but so basically there would be, looking back at that platform, there would be one hub area where the where there's a storage account or a workspace which stores state for that platform landing zone. And then there's 3 layers to this basically. There's the platform landing zone, which is like the starting point. And then there's a subscription vending, which might include, like I say, identities, networking. It might include repositories and source control. Everything that a development team needs to start working on an application. That would also need a state file, and that's usually managed by a central team. So it'd probably sit in that hub area. And then when it's vending that subscription and it's setting up the repositories and the identities and everything, it's also going to set up another storage account there, which the application teams can then use for deploying their infrastructure as code for their own applications. And they might break their applications into different layers inside there, but that's up to that team, I would say, how they want to structure that. They could have one big state file for everything, or they could have multiple state files inside there, depending on how they want to layer it. But yeah, there's 3 like 3 layers to that state management across Microsoft Azure at this point in time. So hopefully I explained that.
Yeah, no, that's actually exactly how it typically goes. So I think the common question people is like, why aren't these opinionated, right? Like, why can't I just find a resource in which it gives me a very strong opinion about how I should be subdividing these resources? And if you are mapping this kind of model to HCP Terraform or Terraform Enterprise, typically a common way to do this is to logically group state by business unit. So each of these layers have their own workspace. Or if, let's say, you are subdividing the application specific layer into the application itself plus the database, et cetera. If you are subdividing those go into what is called an HCP Terraform or Terraform Enterprise workspace. And that has its own individual state. But from a logical grouping perspective, if you wanted to examine what business unit is provisioning or deploying each set of each resource in each state, you can use what is called a project, and the project kind of groups them all together. So a common example of this is that an organization has these business unit identifiers, right? And so they'll group projects based on these business unit identifiers. And then within these business unit identifier projects, there are individual workspaces for resources tied to certain applications, certain infrastructure resources, networking, et cetera, subdivided by workspace. And so it's I think that's the most common subdivision and mapping across Azure, deciding which grouping of Azure resources you want, and then mapping them into Terraform. If you are using Terraform Community Edition, a lot of this is something you'll group yourself. But what I do recommend in general is make sure part of however you're naming your state or however you're naming your repository, try to figure out a way to name them in a standardized way, because at some point you will have to go look for which configuration ties to which state. And it may not be completely obvious.
Yeah, agreed.
Yeah. Mm-hmm. Okay, so we have quite a few other topics to chat about, which is, we've talked a lot about starting provisioning, getting started, setting foundations to scale infrastructure as code. But how do you handle day 2 operations? I think this is something that we have a lot of debate about, because sometimes there are break glass changes that need to happen, emergency changes, because let's say CPU is spiking or something. CPU usage is spiking, utilization is spiking on an instance, and you just need to do something, right? And you manually go in, make those changes, right? And now you've introduced drift, right? Or common thing is maybe you're testing your network policy or your network security group, whether or not you opened up the correct port. And you just go in, you manually update it, and then now you've introduced drift, right? So there's a difference between what Terraform perceives to be the desired configuration and the actual live configuration in Azure. So how do we handle day 2 operations at scale, right? Is there an approach? Is there one approach that allows us to do this across our entire organization? Or, do we just lock everybody out and make sure they're not doing any manual changes?
Yeah, it's good. It's a good question, it's a difficult one. Yeah, drift detection is the subject that we're talking about here. How do you know if somebody's gone in and made a change, but also how do you allow changes to be made out of band in an emergency? I'm not going to say that you have to, in an emergency when you're losing money as a business, I'm not going to say you have to submit a pull request into source control and like promote it up through the different environments. And I appreciate that's not realistic, right? Hopefully most changes go through that route, but yeah, in an emergency thing, somebody's one just go in there and make the fix. If as risky as that is, that's what they're going to do. So ideally, that would immediately be fed back into the desired state in your Terraform code. But again, that might not always happen. So you need some kind of backup to find those changes that have happened, and either fix them if it's an incorrect change, or bring it into the desired state. And your drift detection is the way to do that. So basically, with drift detection, you're going to run a plan against your so comparing your desired state to your actual state. And if that plan comes up with any changes, and you've not made any changes to your desired state, then you know that something is different. And it could be that somebody's gone in there and fixed something. It could potentially be something else, like it could be some upstream API has changed, and now you get in something showing different. But it would find those issues where somebody's gone in through the portal or run a script to make a change, and that change may or may not be correct. If it is correct, then the action from that would be update the code and commit it to source control. If it's incorrect, then you can run another Terraform apply and correct that change, that drift, and bring it back into line with what your desired state is. In terms of building that capability yourself, or does something exist in Azure to do that? The answer is no. And it is a difficult, it's something that you would have to craft, and it can be quite a complex thing to build yourself. So I know that HCP Terraform does have that capability built into it already, and it's got alerting and actions and things like that. So it might be something that you want to consider if as a reason for looking at HCP Terraform. I would say.
Yeah, it does have for those who are trying to find what it is called drift detection in HCP Terraform Enterprise, and it's under what we bundle as sort of a health assessment. So it will proactively run each day and detect drift in the Azure environment and let you know that there's a difference between the Azure environment and your Terraform, what is in Terraform state. And you have the option of reconciling the two by doing what is called refresh plan or refresh only plan. So it brings it back into Terraform state. But as a general recommendation, if you have attributes that are being changed and they're heavily changed or edited in the live environment, you should bring them back into source control. So what it will not do, what HCP Terraform or Terraform Enterprise will not do, is commit those changes back into your version control, right? So it won't do that. But what it will do is that if those changes are acceptable, they are what you expect, it will bring it back into Terraform state, at least, so that next time you run Terraform, you're not going to override those changes, right? Because the fear is, like, let's say you did have to open up a port in production because something went down or something, and then you suddenly run Terraform and apply it, it will overwrite those changes if Terraform doesn't find it in state. So that's why drift detection allows you to just do the refresh, so it brings it back into state and that you don't override it. And so that's one of the things that you can do more proactively. You have some kind of proactive drift detection. But there are also many other day two operations that we can mention, which is including refactoring, right? Eventually, you'll find that your modules or your Terraform root modules have too many resources, or resources that you should be moving out somewhere else. Or maybe someone developed a module and you do want to move existing resources into a module. And so Terraform also includes import capabilities. You can move resources between states. You can remove resources from out of state as well. So there are options for you to move resources around and to refactor. Some of them are more declarative. They can be done in code. For example, import can be done in code, removal can be done in code, or just generally just refactoring. It could be done through code. Others, you do have to do a combination of CLI and doing it in code. So there are different patterns there, but as you scale, you'll find yourself constantly refactoring. And so you'll find that those actions are available for you to remove resources as you need to, or move them into different state as you need.
Yeah, and I do recommend looking at the declarative options for that. The import, moved, and removed blocks are the best way to do that. I would only fall back to using the CLI if there's literally no other option, or going in and manipulating the state file, which would be like the worst case scenario. Don't do that.
Yeah. Don't manipulate the state file. People should not be accessing the state file directly. I think that's also worth, I mean, we were going to talk about this anyway at this sort of a wrap up of like, what are security and compliance practices, especially if you are in a highly regulated industry, but don't give people access to the state file if you can avoid it to the direct state file.
And just building on that, don't store secrets in Terraform either, right? Don't generate secrets, and basically if you touch anything with Terraform, it's going to store it in the state file in plain text, unless you're using what's called an ephemeral or write only attribute, which is available in later versions of Terraform. But many things that you'll be there's limited capabilities around that at the moment. So historically, anything that you touch with Terraform is stored in the state file in plain text. You need to be making sure that you secure that state file, but ideally don't put it in there in the first place.
No, use ephemeral resources. If you need to generate it, or you need to, let's say, generate a password and then set it into, let's say, a database or something like that, as part of the Azure resource, use ephemeral resources, use the key vault, whatever is available and supported through the Azure provider, Azure RM provider, and you set write-only arguments, which basically means no one can read those arguments out, right? They are something that you will have to go, and as long as you have access control to the secret in Azure, for example, Azure Key Vault, then you can read them out. So just be aware of that. And before we move on to the sort of last set of topics, it is worth mentioning day 2 also includes cost management, right? So we talked about policies for quotas and for potentially just for general cost management. But I think at some point, a lot of organizations start realizing that they have environment sprawl or resource sprawl, and they need to start managing the cost of development environments. And the answer isn't always remove every non-prod environment, but there may be other techniques that you can think about on day 2 for managing costs. So that could include adding policies to control what kind of instances are being created, identifying which lower environments are being created, or ephemeral environments, which are a common pattern if, let's say, you're doing module testing or something else. So are there any other tips and tricks that you have for cost management?
No, definitely. I think lower environments is probably one of the biggest areas for that. Like turning them off when you're not using them, or tearing them down when you're not using them. Like, because if you've not got developers working overnight and over a weekend, and you're running those resources in like a test environment, is costing you money when it's not necessary. But yeah, in more advanced customers, I do see ephemeral environments. So the environment is spun up just when it's needed. So maybe when somebody raises a pull request, at that point, the environment's spun up so it can do the end-to-end testing or integration testing. And then once the pull request is merged, that environment is blown away, so it's not there anymore. And to achieve that, you do need infrastructure as code, right? There's not another realistic way of achieving that level of sophistication. So that's another, and for that environment to be representative of your production environment, it has to be the same code that you're using to deploy your production environment. So it is critical from that perspective. Otherwise, any testing you do there is just invalid. Basically, it's not worth doing.
Yeah.
So
And if you did like that, because in HTTP Terraform and Terraform Enterprise, there is an ephemeral workspace capability where you can set a lifetime for that workspace to exist before it gets automatically destroyed. If there have been times where, we've set ephemeral workspaces, or in Azure, for example, we have a cleanup bot that goes through and cleans up all our resources. Or in our case, we also have sandboxes where the sandbox only has like a 15-day lifetime. We can do whatever we want within the sandbox, but it's got a very limited time to live. And if it goes away, you have to rebuild it. And the only way I would be able to rebuild it is because I can rerun infrastructure as code and apply all those changes. And they could be hundreds, if not, thousands of resources deep. So, I'm not going to sit there and click and manually reconstruct it. Instead, what I'm going to do is just rerun it. And I have my sandbox, a new sandbox up and running in the matter of a couple hours, rather than, going through and rebuilding over another 15-day window. So it's a different pattern, but it also means that it's a more popular pattern for cost management as well as for security, right? It's allowing security teams to give some kind of administrative or elevated access for testing and for development without necessarily keeping a long-lived environment around where it could be exposed.
Yeah.
Mm-hmm. All right, so we're at the last topic. Let's see if we have other things that we wanted to talk about, but we're at the last topic. We're close to the top of the hour, but what are some security or compliance practices that regulated industries in particular should be aware of whenever you are writing and deploying infrastructure as code?
Yeah, so I think probably for me, the one that comes up most with customers is the credentials that they're using to deploy their infrastructure as code. I see this question coming up over and over again because historically a secret was required or a certificate to do that. If you were using what's called an app registration or a service principal in Azure, you used to supply a client secret and you had to store that client secret somewhere. If that client secret got into logs, it was unusual for that client secret to be rotated. So obviously there's tools like Vault that can do that for you, but I would suggest that you look at using OpenID Connect for any of that authentication for the accounts that you're using to deploy your infrastructure with, because then you've got a very short-lived secret that goes away at the end of the deployment, and that's supported with any of the tooling that we've talked about already. So we also call it Workload Identity Federation in Azure if you want to look it up. But basically, that's the best approach for securing those credentials and making sure that somebody can't get at them. And it also provides the ability to be very granular. You can have an identity per thing that you're deploying to, so you don't need one identity that's got wide access to everything. You can be very granular in the permissions that identity has, and there's like no extra cost involved in doing that. And it also means that you can I forgot what I was going to say, but carry on. Yeah.
Does this apply for like least privilege for plan and apply? Because it would
that's exactly what I was going to say, and that's what I forgot. Yeah. So we also recommend, my team recommend having a separate identity for plan and apply. So the plan identity has read access, and the apply identity has read-write access. So that basically when you're doing that approval between the plan and the apply stage that we talked about earlier, you're approving that somebody can use that identity that has that write access. That's what you're approving basically there from a security perspective. But you can do all your pull requests and your continuous integration and your testing with an identity that doesn't have that write access, or at least to the plan stage of things anyway.
Yeah. So, yeah. And it's also worth pointing out that sometimes a plan, right, you don't want, if someone does need those credentials or does end up using those credentials for a plan, right, you don't want them to necessarily go away and make those changes. Some of these things you do, there's a reason why there's an approval process.
Yes.
So separating the two ensures the least privilege between those two separate stages, especially if you have a manual stop right in the middle of the between plan and apply. This is common in the United States, where SOX compliance for financial services, right, is a big factor, where you need 2 approvals in order for something to go to production. And you may have some additional automation there to just make sure those 2 approvals are indeed correct and approved before moving forward. So it just ensures that if it is a long-lived, potentially like a long-lived plan, or a plan that's kind of held there, so if someone does end up using those credentials, they're not going to be able to make any changes.
And I, when you're deploying to a production environment, I would always recommend having, at this point in time, always recommend having that manual intervention at that point. Don't just do a plan and apply with an auto approve straight through to production, like, unless you're really confident. I think having that stop, even though it's sort of a break in the process and can slow things down a little bit, it's definitely worth doing, especially in a regulated industry.
Yeah, exactly. Yeah, you do want an additional review, right? So effectively, you can think of it as change review. You don't have to gate these things necessarily, maybe to development environments or lower environments, but certainly before production. And I think there's also a couple other points that, from a security perspective, that you should be considering. We talked about it before, using policy as code to enforce, or Azure policies to enforce what resources can be provisioned, cannot be provisioned, and then limiting the portal access, right? Making sure that if you can, all changes go through version control. If someone does need access to the portal in order to make a change, it's temporary. Make sure it's ephemeral. And it's least privileged. And then ephemeral resources to protect secrets in state, because they will be in state, and protect state itself. Not everybody should be accessing it directly. And then there's a couple more practices that come up, especially if you're in a regulated industry, which is verifying modules. They are artifacts, so you do want to make sure that they do contain verified and approved configuration for your organization, whether they are public modules or private modules, and make sure that their distribution is controlled as well. Make sure your version pinning, especially if you didn't approve certain versions of modules. And the sort of the last practice, just to keep in mind, is if you are in an organization that has a some kind of chargeback model, or has some kind of compliance requirement, tagging is extremely important. So label your resources, use modules to help facilitate and make sure those tags are consistent. But that goes a long way to helping with billing or compliance and audit. Anything else we missed on the list, Jared?
I don't think so. I think that was everything we were hoping to cover.
Yeah. We got through everything.
It
was a lot. It was a lot. As we wrap up, do you have any final thoughts? Any advice that you give to someone who's considering, introducing Terraform into their organization to handle their Azure infrastructure and configuration?
So I definitely suggest looking at our cloud adoption framework and our well-architected framework. There's a wealth of material in there, and it gives you opinionated guidance about how to secure and do cost optimization, how to structure that Azure landing zone as well. All that information is in there. I also suggest looking at Azure Verified Modules if you haven't already. Like, as a minimum, you can steal our code and use it, right? Even better, you can just use our modules and save yourself the effort of building your own modules. Those are the high level things that I'd suggest people do now.
Yeah, and if you are trying to scale your Terraform deployment, you're expecting multiple teams to use it, check out HCP Terraform or Terraform Enterprise. It has a module registry, which allows you to control the distribution of modules. It has drift detection, which we talked about before, so you can check it out, see if that helps with some of the things you're looking to do at scale. And if you are writing Terraform, go to developer.hashicorp.com. There are documents on how to use Terraform, writing your own modules, and there's a style guide as well. So if you are looking to improve your overall Terraform code hygiene, right, we have a style guide so you can make sure it's consistent across your organization as well. With that, I think we are going to wrap up. Thank you all for joining us today. If you have any additional questions, feel free to reach out to us. And if you are interested in replaying this recording on demand, it will be on the Reactor YouTube channel. With that, I'm going to pass it back to Moria.
Thank you so much. Thank you, Rosemary, and thank you, Jared. That was a really great session, very interesting, and I enjoyed it. I hope you enjoyed it as well. As Rosemary said, that the event was recorded and available on the Reactor YouTube channel. I know we're a bit over time, so those of you who had to drop, you can listen to the recording later. Thank you again, everyone, and thank you, Rosemary. Thank you, Jared, and goodbye. Bye-bye.
Thank you.